world's most popular luxury sedans. Like the factory in which it's built, Daimler's flagship, the S-Class, is packed full of high-tech. In its seventh generation since 1972, the 100,000 euro car shares an assembly line with its electric sibling, the EQS, and the world-famous Maybach. Building conventional hybrid and electric luxury class cars on a single production line is unique in the automotive sector. Located in the main Mercedes plant in Sindelfingen, Factory 56 covers 220,000 square meters. The mega project took 2.5 years to build and cost 730 million euros. With its innovations, the high-tech factory is akin to a journey into the future of automotive manufacturing. The aim here is to produce the S-Class, Maybach & Co. in the most sustainable and eco-friendly way possible. Inside, the group is now building its luxury sedans 25% more efficiently than in the old hall next door. In the naturally lit mega factory, people and machines are part of a digitally networked whole. 2,000 workers, dozens of robots, and hundreds of autonomous transporters operate like clockwork to produce the new S-Class generation, the EQS electric sedan, and the luxurious Maybach. The classic assembly line has made way for highly efficient series production.
We can produce conventionally powered, hybrid, and also fully electric vehicles on a single line here. This is an innovation and a global first. But not only that, we can also produce sedans or SUVs, compact cars, the Maybach, or even fully electric vehicles here in this building.
One of the 400 automatically guided vehicles, or AGVs, is heading to the first S-Class production station. The special feature of these fully electric production aids is their flexibility. Depending on use, they can be fitted with various special bodies, allowing them to perform diverse tasks. Once a minute, the computer-controlled logistics system in the suspended ceiling loads the AGVs with freshly painted body shells. Over the next few days, the cars pass through hundreds of assembly stations until a new Mercedes S-Class is finally produced. Top model in the new Mercedes-Benz S-Class range bears the name S580 4MATIC. An impressive 523 horsepower can accelerate the 2 metric ton sedan from 0 to 100 kilometers per hour in 4.4 seconds. The V8 bi-turbo engine with a displacement of 4 liters is electronically limited to 250 kilometers per hour. Depending on equipment and interior comfort, the luxury sedan costs upwards of 130,000 euros. In Sindelfingen, each car starts its life with these coils, rolls of sheet steel or aluminum weighing several tons. The unrolled material passes through a laser blanking system, where 3 lasers precisely cut out shaped panels that are subsequently used to manufacture the body. The cutting heads operate at up to 100 meters per minute, and therefore produce 12,000 blanks a day. At the end of the day, the machine has consumed 72 coils, an unimaginable number for previous pressing and cutting methods.
The laser blanking system is fully flexible in terms of the components that can be produced on it. Previously, a cutting tool was needed for each component, requiring lots of space and conversion time. Today, everything is programmed in the system and can be switched over very quickly to a different component that's currently needed to meet customer demand.
The system spits out a batch of S-Class sidewalls. 300 blanks, each weighing 15 kilograms, are stacked on the carriage. The aluminum plates don't look anything like a car yet. Brute force and a gigantic machine are needed to transform the flat sheets into a new sedan in the press shop in Sindelfingen. 110 meters long, 25 meters wide, 12 meters high. This servo transfer press is a pure superlative. The workers feed the hungry system in Hall 17 using an overhead crane. Several hundred blanks disappear into the giant's press maw each hour. The rest then takes place fully automatically. Inside, up to 6 individual pressing stages await the metal sheet, depending on the component being produced.
Browsing flights and start booking them. The UK has quaint villages to explore. Italy has Roman monuments.
Like a gigantic anvil, the flat blanks are mechanically punched, formed, and bent between the 2 clashing die halves.
We give the vehicle its face here. The blank is flat and we turn it into a molded part.
The dies, as the red press molds are also called, operate with a force of 2,500 metric tons. Molds for engine hoods, trunk lids, roofs, door panels, or side panels are stacked several meters high alongside the system. It takes the team just 1 hour to exchange one of the 60-ton dies in the servo transfer press. Then the process can continue with full force.
For the sidewall, we run at 15 strokes per minute, or 900 per hour. I can run some components even faster. That depends on the structure, the geometry, and the material, whether it's steel or aluminum. So the system can do more, but it usually runs at around 15 strokes or 900 parts per hour.
Each part coming from the press shop is checked by trained quality inspectors. Body panels with hairline cracks or deviations are detected and rejected here early on. The body of the S-Class has always made a statement. Mercedes has been building its special class since the early 1970s and has made the car one of the world's most successful luxury class vehicles ever, with over 4 million models sold. From the press shop, the formed body panels proceed to the body shop. Covering an area of 100,000 square meters, the body shop is one of the largest departments in Sindelfingen. This is where more than 1,000 robots weld, rivet, and bond the vehicle's body fully automatically in the tightest of spaces. Thanks to complex software, each of them knows whether it has to produce an S-Class, a Maybach, or an EQS, and adapts its operation steps accordingly. Here, humans are solely responsible for checking and maintaining the systems.
We have a material mix consisting of aluminium and steel, and we use 10 different joining technologies to join these parts. They range from conventional steel spot welding to ultra-modern laser welding.
In the body shop, dozens of puzzle pieces are transformed into a highly complex body in just a few hours. In an emergency, this vehicle carcass has to be able to withstand extreme physical forces. For a vehicle with a weight of 2 tons and a maximum speed of 250 kilometers per hour, occupant protection is given top priority, which is why the steel and aluminum body has been constantly evolved in numerous crash tests. The list of technical innovations that Mercedes-Benz has introduced with the S-Class is long. Since the 70s, the German automotive manufacturer has been building experimental safety vehicles, or ESFs, to test new safety systems and develop them to market maturity. For instance, ABS was first fitted as standard in the W116 model series in 1978. During this period, designers and engineers' focus increasingly shifted to safety in addition to the vehicle's handling characteristics. Crash tests were developed and innovative passive safety systems were invented. The first airbags and seatbelt tensioners were fitted in the S-Class in 1981. Prosperity in post-war Europe led to considerably more cars and much denser traffic on the roads, a change that resulted in new safety needs in society. As a consequence, new crash tests, such as the side impact or the asymmetric frontal impacts, were developed. For Mercedes, the S-Class has always been the pioneer in terms of safety engineering. Technical innovations such as adaptive cruise control or infrared night vision were launched in the luxury sedan at that time. Back to the present. The car bodies that are just leaving the body shop are fully assembled. In the light tunnel, 2 employees thoroughly inspect the surfaces for deviations and polish the vehicle's untreated panels. No machine can take the place of the human eye or the feeling in the fingers, even in one of the world's most modern car factories. Each emerging S-Class continues on its way in this gigantic system. This is where the body goes for a dip. The 50-meter-long dip tanks in the paint shop are filled with a special liquid primer. Now the electricity starts to flow as e-coating begins. E-coating is an electromechanical dip painting method in which the vehicle's body is negatively charged, and the paint in the tank is positively charged. During the dipping process, the body attracts paint particles due to its opposing charge. This ensures that the phosphate-based rust protection gets into even the tightest of spaces in the metal carcass and protects the vehicle from oxidation and cavitation.
Another big advantage of the e-coating dip tanks is that they have an infinite service life. And the materials that we deposit onto the body shell are constantly resupplied as fresh material. So this is actually a resource-efficient cycle.
With just $1, you can start trading. This is not a dream. This is real with the Expert Option app.
This is actually a resource-efficient cycle.